Why each planet follows a circular path around the Sun. It is commonly believed that planets follow circular paths around the Sun. They actually move in elliptical orbits. Elliptical orbits. An elliptical orbit is a stretched-out circle. It is a type of curved path that planets, including Earth, follow around the Sun. In an elliptical orbit, the planet's distance from the Sun varies throughout its orbit. Gravitational force. The force that governs the motion of planets is gravity. Gravity is a force of attraction that exists between two objects with mass. The Sun's enormous mass creates a gravitational pull that keeps the planets in their orbits. Kepler's laws. Johannes Kepler, a famous astronomer, formulated 3 laws that describe the motion of planets in their orbits. These laws are based on observations and mathematical calculations. First law, law of ellipses. According to Kepler's first law, planets move in elliptical orbits with the Sun at one of the 2 foci of the ellipse. The Sun is not located at the exact center of the ellipse, but slightly off to one side. Second law, law of equal areas. Kepler's second law states that an imaginary line joining a planet to the Sun sweeps out equal areas in equal time intervals. This means that a planet moves faster when it is closer to the Sun and slower when it is farther away. Perihelion and aphelion. In an elliptical orbit, the point where a planet is closest to the Sun is called the perihelion, while the point farthest from the Sun is called the aphelion. As a planet moves along its orbit, it experiences changes in its distance from the Sun. Third law, law of periods. Kepler's third law relates the time it takes for a planet to orbit the Sun, its period, with its average distance from the Sun, its semi-major axis. The law states that the square of a planet's orbital period is proportional to the cube of its average distance from the Sun. Circular versus elliptical orbits. While a perfect circle is a special case of an ellipse, most planets' orbits are not perfectly circular. Instead, they have a slight eccentricity, which means they deviate from a perfect circle. The eccentricity determines how elongated or circular an orbit is. Orbital stability. The elliptical orbits of planets ensure their stability. The gravitational pull from the Sun keeps the planets within their orbits, preventing them from flying off into space or falling into the Sun. The balance between the gravitational force and the planet's velocity maintains a stable orbit. In summary, planets follow elliptical orbits around the Sun due to the gravitational force. These elliptical paths, described by Kepler's laws, result in variations in the planet's distance from the Sun throughout its orbit. While the orbits are not perfect circles, they are still stable, allowing the planets to maintain their path around the Sun.